the black water off a Caribbean reef, a diver hangs still as a shape the size of a school bus rises out of the dark. It is a sperm whale, the largest hunter with teeth on this planet, a predator strong enough to crush steel. It could end the moment in one bite. It does not. Sperm whales carry the loudest voice in the animal kingdom, a click 230 decibels strong, powerful enough to rattle bone from 10 feet away. They dive deeper than any submarine built for a diver, hunt giant squid in total darkness, and once sank a ship the size of a small apartment building. But when a human enters their world, something changes. Today we go inside the sound cannon in a sperm whale's skull, the ship that fought back in 1820. And the reason the ocean's true apex predator treats us like we're not even worth the trouble. If you want more of the ocean's strangest secrets, hit subscribe. You will not want to miss what is down there. The deep is waiting. Let's go under. The water off Dominica is warm and clear, and a diver hangs completely still, arms at her sides, watching a shadow grow bigger. It is not a shark. It is not a shipwreck. It is a sperm whale, and it is longer than a school bus, gliding out of the blue like a slow-moving mountain. Her heart pounds. She has read about this animal her whole life. It is the largest predator with teeth on the entire planet, bigger than any shark that has ever lived, strong enough to crack open a small boat like a walnut. In the water, size means power, and this whale outweighs her by more than 500 times. Every instinct in her body says to swim for the surface, to get away, to hide. She does not move. She has been told that sperm whales do something strange when they meet a human in open water. They do not attack. They do not flee either. They simply come close, turn one huge eye toward the tiny creature in front of them, and look. The whale drifts nearer, its skin wrinkled like old leather, its head as blunt and square as the front of a truck. She can see one eye now, dark and round, watching her the way a person might watch a stranger's dog approach on a walk. Curious, careful, not afraid, and not angry. Then, just as slowly as it appeared, the whale turns its massive body and eases back down into the dark, leaving nothing behind but a swirl of bubbles and a diver who cannot stop shaking. This happens more than people realize. Divers, snorkelers, and researchers across the world have filmed dozens of these calm, quiet encounters, and in almost every one, the whale is the one that stays relaxed. That single fact breaks every rule you would expect from the ocean's biggest hunter. Great white sharks size up prey with quick testing bites. Orcas hunt in coordinated packs, chasing down seals with brutal speed. Sperm whales, the biggest hunters of them all, mostly just watch. Scientists studying these whales have logged the same pattern again and again in different oceans, from the Caribbean to the waters off Sri Lanka. The whale approaches, the whale observes, and then the whale leaves. No aggression, no panic, almost boredom. It raises a question that sounds impossible at first. How does the most powerful hunter in the sea look at a human being, a creature it could kill in a single move, and decide we are simply not worth the trouble? To answer that, you have to go back nearly 200 years, to the one time in recorded history when a sperm whale did the opposite, when it chose violence, on purpose, against a wooden ship full of men who had come to kill it. Picture every predator you have ever learned to fear. Sharks patrol beaches looking for movement in the water. Lions stalk herds from tall grass, waiting for the weakest one to fall behind. Even smaller hunters, like wolves or crocodiles, will take a human if the opportunity is right and hunger is strong enough. Now picture the sperm whale, an animal 5 times heavier than an elephant, with the largest brain of any creature that has ever lived on Earth, a jaw lined with teeth the size of bananas. If any animal in the ocean had the size and the tools to hunt people, this would be it. Here is the strange part. In the entire history of recorded human contact with sperm whales, stretching back over 300 years, there is not one confirmed case of a sperm whale hunting a human being for food. Not one. Compare that to sharks, which have been involved in thousands of bite incidents worldwide, most of them cases of mistaken identity, but still direct contact. Compare that to orcas, which despite being called killer whales have their own documented history of aggressive encounters. Sperm whales are different. Scientists who study their stomach contents, cutting open whales that wash ashore after dying naturally, find the same thing over and over. Squid beaks. thousands of them, packed together like gravel at the bottom of a whale's stomach. Deep sea fish, the occasional shark or skate pulled up from 1,000 feet down, never a human. The reason comes down to something surprisingly simple, the same reason a lion does not chase a car. Sperm whales hunt using a picture built from sound, not sight, and that picture is trained by millions of years of evolution to recognize squid, fish, and other deep-sea shapes. A human floating at the surface does not look, sound, or move like anything a sperm whale has ever learned to chase. We are the wrong shape, the wrong size, and in the wrong part of the ocean. Sperm whales do almost all of their hunting 800 to 3,000 feet down, in total darkness, chasing prey that lives nowhere near where humans swim, dive, or surf. A whale meeting a human at the surface is not meeting prey. It is meeting something new, something unfamiliar, floating in a part of the ocean where the whale is not even thinking about food. That gap between us explains most of the calm encounters divers describe, but it does not explain everything. Because if sperm whales never see us as prey, and never see us as a threat worth fighting, then something else entirely must have happened on a November morning in 1820, when one specific whale decided a wooden ship deserved to be destroyed. The whaling ship Essex left Nantucket in August of 1819, sailing toward the far side of the Pacific Ocean in search of sperm whale oil, the fuel that lit lamps and streets across the world at the time. For over a year, the crew hunted whales the way whaling crews always did, chasing pods in small rowboats, driving harpoons into their sides, and towing the dying animals back to the ship to be carved apart for their oil. By November of 1820, the Essex had found a large pod of sperm whales in open water, thousands of miles from land. The crew lowered their small boats and gave chase, just as they had dozens of times before. What happened next had never been recorded before in the history of whaling, and it terrified everyone who survived it. A massive bull sperm whale, reportedly 85 feet long, nearly the length of 3 school buses end to end, appeared near the ship itself. It did not flee. It did not dive. Witnesses said it lay motionless on the surface for a moment, facing the ship head-on, then began swimming directly at the hull, gathering speed. The first strike hit the bow with a force that knocked men off their feet and cracked the wooden planks. The whale then swam off, turned around in the water, and came back for a second run, this time hitting even harder. The second blow shattered the hull below the waterline. Within minutes, the Essex, a ship built from solid oak and meant to survive years at sea, was taking on water it could not stop. The crew abandoned ship in 3 small open boats, thousands of miles from the nearest land, with barely any food or fresh water between them. What followed became one of the most brutal survival stories in maritime history, a nearly 3-month ordeal across open ocean that most of the crew did not survive. The account of the ship's first mate, Owen Chase, describes the whale's approach as deliberate, aimed, and unlike anything any experienced whaler had ever witnessed. This single event became the seed for one of the most famous novels ever written, Moby Dick, and it left a question that scientists are still trying to answer over 2 centuries later. Whales do not normally attack ships, so what turned one massive bull sperm whale into the only confirmed case of a sperm whale intentionally destroying a vessel that was hunting it? For decades after the Essex sank, people told the story as if the whale had simply gone mad, a monster from the deep seeking revenge. The real explanation is less like a monster movie and more like watching an animal being pushed past its limit. By the time the Essex crew encountered this particular bull whale, the ship had already spent the entire morning hunting the same pod. Small boats had chased individual whales through the water, harpoons had been thrown, and at least one whale had already been wounded and was thrashing nearby, its blood spreading through the water. Sperm whales live in tight social groups, and they communicate constantly through clicks that can travel for miles underwater. Some researchers believe the sound of a wounded, panicking whale, combined with the shape and noise of the ship itself, may have triggered something close to a defensive response in the bull that attacked the Essex. Picture a bear defending a den, or a mother elephant charging a jeep that has gotten too close to her calf. This was not hunting behaviour. It was protection, aimed at the one thing in the water big enough and loud enough to seem like the source of the danger, the ship itself. There is another detail that makes this theory stronger. Sperm whale skulls are built in a way that almost nothing else in the ocean can match. The front of the skull, called the junk, is packed with dense, fibrous tissue layered like the crumple zone in a modern car, built to absorb massive impact without damaging the sensitive sound organs behind it. Scientists studying the physics of the Essex collision found that a whale of that size swimming at full speed could generate enough force to crack open a wooden hull without seriously injuring itself. In other words, this whale's body was already built for exactly the kind of impact it delivered that day, whether by accident of evolution or not. Recent studies have gone even further, capturing footage of male sperm whales appearing to headbutt each other during competition for mates, evidence that ramming with the skull might already be part of natural sperm whale behaviour. If bulls are willing to use their heads as weapons against each other, using that same weapon against a wooden hull that smelled and sounded like the source of an attack on their pod becomes far less mysterious. The Essex was not proof that sperm whales hunt humans. It was proof of what happens when a sperm whale is directly, repeatedly harpooned by the very ship it eventually destroys. And that distinction matters, because it means the calm, curious whales divers meet today are not holding back some hidden violence. They are simply behaving the way sperm whales have always behaved, when nobody is trying to kill them first. To understand why sperm whales leave people alone, you have to understand what actually makes it onto the menu, and the answer might surprise you. A single adult sperm whale eats roughly 1 ton of food every single day, an amount equal to about 10 adult humans in total weight, disappearing into one's stomach before the sun rises the next morning. Almost none of it is fish. The overwhelming majority is squid, not the small squid people eat on a plate at a restaurant, but deep-sea squid of every size, from creatures smaller than a house cat to giants over 30 feet long, hauled up from some of the darkest, coldest water on the planet. Scientists have cut open stranded sperm whales and found stomachs packed with thousands of squid beaks, the one part of a squid that does not digest, stacking up over the whale's lifetime like receipts in a drawer. Along with squid, sperm whales eat deep-sea fish, skates, the occasional small shark, and other creatures that live far below where sunlight reaches, in a zone of the ocean humans almost never visit without a submersible. This is the key detail. Every single meal a sperm whale hunts lives in near total darkness, somewhere between 800 and 3,000 feet down, in freezing, crushing water where a human without serious equipment would black out and die within minutes from the pressure alone. Humans do not live there. We do not swim there. We barely visit there, even with modern technology. A sperm whale's entire hunting instinct, built over millions of years, is wired to detect prey in this specific, dark, deep, and empty world using sound instead of sight. When a sperm whale rises toward the surface where humans actually are, it is not hunting anymore. It is often resting, breathing, or socializing with its pod, activities that have nothing to do with food. This explains something researchers have noted again and again when they study these calm encounters between divers and whales. The whale is simply not in hunting mode when it meets a human, because humans exist entirely outside the part of the ocean and the part of the whale's daily routine where hunting happens. It would be like a person walking through their own living room encountering a rare bird they have never seen before. There is curiosity, maybe even excitement, but the thought of eating it never enters the picture, because that is simply not what this moment, or this place, is for. But food is only half the story. The other half is the weapon a sperm whale carries in its head, a weapon so powerful that some scientists once believed it alone could stop prey in its tracks, before the whale even opened its mouth. A sperm whale's head is unlike anything else in the animal kingdom, and it takes up nearly 1/3 of its entire body length. Inside that massive block sits a structure scientists call the junk, a dense, fibrous mass layered like sheets of tough cartilage stacked one on top of another, built to absorb enormous force without breaking. Above the junk sits the spermaceti organ, a huge sac filled with a waxy, oil-like substance that whalers once mistakenly believed was something else entirely, which is how the whale got its name. For centuries, sailors told stories of male sperm whales using their massive heads as weapons, ramming rival males during fights over mates, and even ramming ships, the way the Essex was struck in 1820. For a long time, scientists dismissed this as exaggeration, an old sailor's tale passed down and stretched with every retelling. Then, using computer models that simulate exactly how force travels through bone and tissue, researchers tested what would happen if a sperm whale rammed something headfirst at full speed. The results were remarkable. The layered structure of the junk works almost exactly like the crumple zone engineers build into the front of a modern car, a system designed to absorb a crash without transferring all that force to the passengers inside. In a sperm whale, the passengers are the sensitive sound organs packed just behind the junk. Organs the whale depends on to survive in the pitch-black depths. The structure lets a bull whale deliver a devastating blow to a rival, or apparently to a wooden hull, while protecting the exact tools it needs to hunt again the next day. In 2026, marine biologists captured something scientists had debated for over a century: video footage of two male sperm whales appearing to headbutt each other, confirming what sailors had claimed for 200 years. This weapon exists almost entirely for one purpose: competition between males fighting for the chance to mate, not for hunting prey, and certainly not for encounters with humans. Squid, the whale's actual food, are never rammed. They are hunted using an entirely different tool, one that does not require any physical contact at all, a tool so powerful that scientists once wondered if it alone was capable of killing prey before a single tooth ever touched it. Sit inside a sperm whale's skull for a moment, and you would find one of the strangest pieces of natural engineering anywhere on Earth. The spermaceti organ sits at the very front of the head, a long sac filled with a clear, waxy oil that has a special property. Its density changes slightly with temperature, and scientists believe the whale can control that temperature just enough to fine-tune the organ like an adjustable lens, but for sound instead of light. Below the spermaceti organ sits an air-filled chamber that acts like a mirror, bouncing sound waves back through the oil a second time before they finally leave the whale's head in a tight focused beam pointed straight ahead. Think of it like the difference between a bare light bulb and a flashlight. A bare bulb throws light everywhere at once, weak and scattered. A flashlight takes that same amount of light and focuses it into a single powerful beam that can reach across a dark room. The sperm whale's head does exactly this with sound, taking clicks generated deep in its nose and focusing them into a beam aimed forward into the darkness. This system did not evolve by accident. It evolved because the deep ocean, the whale's actual hunting ground, is a world without light. Below about 3,000 feet, sunlight cannot reach at all, and even bioluminescent creatures only provide faint scattered glimmers. A sperm whale hunting in this environment cannot rely on its eyes, the way a lion relies on eyesight to spot prey across a grassy plain. Instead, it builds an entire picture of its surroundings using sound alone, sending out a click and listening for the echo that bounces back. The same basic principle used in submarine sonar, except this system evolved millions of years before humans ever built a submarine. Every ridge of the ocean floor, every hidden squid, every rock formation gets mapped inside the whale's brain using nothing but returning sound. This is remarkable enough on its own, but what makes the spermaceti organ genuinely frightening is not its precision. It is its raw power, a sound so loud that scientists still argue about what it might actually be capable of doing to a living creature standing directly in its path. Numbers on their own rarely mean much, so picture this instead. A chainsaw held 3 feet from your ear measures about 140 decibels, loud enough to damage your hearing within seconds if you're not wearing protection. A jet engine at takeoff reaches roughly 150 decibels, a sound so intense it can be genuinely painful to stand near. The loudest rocket launch ever recorded by NASA, the Saturn V in 1967, thundered out at around 204 decibels, a sound so powerful it shook buildings miles away. Now picture a sperm whale's echolocation click, measured underwater at up to 230 decibels, and in some recordings even higher. That number does not sound like much more than the rocket launch, until you remember how sound behaves differently underwater than it does in air. Water is roughly 800 times denser than air, which means sound waves travelling through it carry dramatically more physical force per square inch than the same decibel level would carry through open air. A 230 decibel click underwater is not simply louder than a rocket launch. It is a wall of pressure moving through liquid, striking anything in its path with real physical force, not just noise. This makes the sperm whale's click the loudest sound produced by any living creature on Earth. Louder than a blue whale's song, louder than any dolphin, louder than anything a human engineer has managed to build that can fit inside a single animal's skull. Sperm whales can hear each other's clicks from tens of miles away across open ocean, an entire hidden language broadcast through water that most of the surface world never even notices. For most of the 20th century, scientists studying this sound assumed its only purpose was navigation, a biological sonar system for finding food and mapping the dark ocean floor. Then, in the 1980s, one researcher noticed something strange sitting inside the stomachs of dead sperm whales, something that would completely change how people understood this sound and would eventually raise a genuinely unsettling question about what happens to any living thing caught directly in a sperm whale's beam. In the 1980s, a marine biologist named Kenneth Norris noticed something odd while examining the stomach contents of sperm whales that had died and washed ashore. Squid beaks, hundreds of them, packed inside without a single visible bite mark or sign of struggle on the surrounding tissue. For an animal that hunts fast, intelligent prey capable of jetting away in a burst of speed, this seemed strange. Squid are quick, alert, and built to escape predators using sudden bursts of movement. If sperm whales were chasing down each meal the way a shark chases a fish, you would expect signs of struggle, torn tissue, evidence of a fight. Norris proposed a theory that sounded like science fiction at the time. What if the whale's loudest clicks were not just used to find prey, but to briefly stun it, the underwater version of a flash grenade going off in a hallway, disorienting or even paralyzing a squid just long enough for the whale to close the distance and capture it before it could react? The idea made a strange kind of sense. A sperm whale's click, focused forward through the spermaceti organ like a beam, could theoretically strike a nearby squid with a wall of pressure intense enough to overwhelm its nervous system, especially since squid, like most soft-bodied sea creatures, have no bones or hard structure to absorb a shockwave the way a human skeleton might. For decades, this stun theory captured public imagination, showing up in documentaries and articles describing the sperm whale as an animal armed with a sonic weapon capable of debilitating prey from a distance. If true, it would mean the loudest sound on Earth exists inside a living animal's head, specifically to disable other creatures before a single tooth makes contact. It would also raise an uncomfortable question about exactly what that same sound could do to a human diver caught too close during a hunt. But not every scientist who studied this theory came away convinced, and the real answer turned out to be far more complicated than a simple yes or no. Science rarely settles a mystery this cleanly, and the sperm whale's sonic stun theory is a perfect example of a question that refuses to close. After Kenneth Norris proposed his idea in the 1980s, other researchers spent years trying to actually test it, and the results have pulled in different directions ever since. Some studies exposed smaller sea creatures, including fish, to intense underwater sound pulses similar in strength to a sperm whale's click, and found real physical effects, including signs of internal stress consistent with a stunning impact. Other research teams tried playing recorded whale clicks at realistic volume directly at swarms of prey animals in controlled conditions, and found no measurable harm at all, casting serious doubt on whether the theory holds up outside a laboratory. The disagreement partly comes down to a problem nobody has fully solved. No scientist has ever directly filmed a sperm whale in the exact moment it captures a live squid at full hunting depth, thousands of feet down in complete darkness, because building equipment tough enough to survive that pressure while somehow staying close enough to record clearly remains an enormous engineering challenge. Without that footage, researchers are left working backward from clues, empty squid beaks without bite marks, patterns in echolocation recordings, and educated guesses about anatomy rather than a clear recorded answer. What most scientists do agree on is this: even if the stun theory turns out to be only partly true, or not true at all in the way Norris originally imagined, the click itself remains an astonishing biological tool, precise enough to detect a squid the size of a house cat from hundreds of feet away in total darkness. Some researchers now lean toward a middle ground, suggesting the click's main job really is detection and tracking, similar to submarine sonar, while any stunning effect on very close prey might simply be a side benefit rather than the primary weapon. This unresolved debate makes the next question even more unsettling. Because whether or not the stun theory is fully proven for squid, scientists do know one thing for certain about what happens when that same sound hits something far softer and far more fragile than a squid. Something built more like us. Humans are not built for the kind of sound a sperm whale can produce, and the science behind why is straightforward once you understand how the human body actually experiences noise. Sound above about 130 decibels in air is already painful to the human ear, capable of causing permanent hearing damage in seconds. This sperm whale's echolocation click, even measured conservatively, reaches roughly 200 decibels in air equivalent, and far higher underwater, a level scientists say is intense enough to potentially rupture a human eardrum on direct exposure at close range. But hearing damage might not even be the most serious risk. The human body is mostly water, and tissues with different densities like the lungs, sinuses, and inner ear respond very differently to a sudden pressure wave passing through them. Marine biologists studying underwater blast injuries in other contexts, including sonar testing and underwater explosions, have documented real physical damage in exposed tissue from intense pressure waves alone, separate from any actual physical contact. A sperm whale click at close range, within just a few meters, delivers exactly this kind of pressure wave, and researchers believe it could realistically cause disorientation, nausea, or worse in a human caught directly in its path. This is not a common danger divers actually face, and there are no confirmed cases of a sperm whale's click seriously injuring a human, largely because whales tend to click while hunting at depth, far from where people are typically in the water, and because whales generally do not aim these hunting intensity clicks directly at something they are not trying to eat. Still, the physics is real, and it reframes every calm underwater encounter divers describe. When a sperm whale approaches a human and stays quiet, using gentle, quieter, social clicks instead of its full hunting intensity blast, that silence may be a choice, not a limitation. The whale has the loudest weapon on the planet sitting inside its own skull, aimed and ready, and in every recorded peaceful encounter, it simply chooses not to use it. That restraint becomes even stranger once you realize sperm whales seem to interact with human eyes and faces in a very specific, almost careful way, a behavior that hints at something more complex going on inside that enormous brain. Divers who have spent real time near sperm whales describe a small detail that keeps showing up across completely different encounters, in different oceans, with different whales that have never met each other. The whale rarely stares straight at a human's face for long. Instead, it tends to angle its massive head slightly to the side, watching with one eye, almost the way a person might glance at something out of the corner of their vision, rather than turning to look directly. Sperm whale eyes sit on the sides of their heads, so this angled approach may simply be a practical way for the whale to actually see a small, close object clearly, since looking straight ahead with both eyes may not give it the clearest view of something as small as a human body. But researchers who study animal behavior point out something else worth considering. In many highly social animals, including primates and dogs, a prolonged direct stare can function as a challenge or a threat, while an angled sideways glance often signals calm, non-aggressive curiosity instead. Sperm whales are deeply social animals themselves, living in tight family pods and using an entire system of clicks called coders to communicate specific information to each other, almost like a spoken language. It is possible, though far from proven, that some of that same social awareness carries over into how a whale approaches an unfamiliar creature like a human. Instead of an aggressive direct stare, the whale offers something closer to careful observation, the body language of an animal that is curious, not hunting, and not threatened. This lines up with something researchers have filmed repeatedly. Whales approaching divers slowly, adjusting their speed and distance without any hurried movement, sometimes hovering just far enough away to observe without ever closing the final few feet, unless the diver stays calm and still long enough for the whale to feel comfortable coming closer on its own terms. None of this proves that a sperm whale understands eye contact the way a human does, but it does suggest an animal that is reading its environment carefully, making a deliberate choice about how closely to engage, rather than reacting on pure instinct alone. To understand where that kind of careful behavior might come from, you have to go back to the one sound a sperm whale makes that has nothing to do with hunting at all, a sound so specific and so loud that terrified sailors gave it its own nickname centuries before anyone understood what it actually meant. Long before scientists had underwater microphones or any real understanding of echolocation, 19th century whalers already knew something was strange about the sounds coming from beneath their small wooden boats. Sailors described hearing a sharp, explosive crack travelling up through the hull of their boats, a sound so sudden and so loud that they gave it a name that stuck for generations: the gunshot click. Modern researchers, recording sperm whales with specialised underwater equipment, have confirmed that this sound is real, and it is different from the steady clicking pattern whales use for normal echolocation. The gunshot click is louder, sharper, and more explosive, sometimes reaching over 220 decibels in a single burst, and it tends to show up in very specific situations, often produced by large adult males and often occurring when another whale, boat, or unfamiliar presence has come close. Scientists are still working out exactly what triggers it and what it communicates, but the leading theories point towards something between a warning and a display. In some recordings, gunshot clicks appear right around moments of tension, competition between males, or an unfamiliar boat approaching a pod too quickly, suggesting the sound may function less like a hunting tool and more like a message aimed directly at whoever, or whatever, is nearby. Think of it the way a dog might growl low in its throat before a stranger gets too close. Not necessarily a sign that an attack is coming, but a clear signal that says, "I see you, and I want you to know I see you." For sailors 2 centuries ago, hearing this sound rattle up through the wooden hull of their small boat must have been genuinely terrifying, an unmistakable message from something enormous and unseen just beneath the surface. For modern researchers, it offers something more valuable than fear. It offers a clue that sperm whales are not simply reacting to the world around them on pure instinct. They appear to be communicating specific information, adjusting their sounds based on context, choosing different clicks for different situations. An animal capable of that kind of nuanced signalling is also an animal capable of learning, remembering, and passing knowledge down to the next generation, including painful lessons about exactly which ships in the ocean deserve fear and which ones do not. Long before Owen Chase ever wrote about the Essex, whalers across the Pacific already told stories about one particular sperm whale, an enormous pale-coloured bull that had earned a nickname of his own, Mocha Dick, named for the waters near Mocha Island off the coast of Chile where he was most often spotted. For years, whaling crews described him as unusually large, unusually pale, almost white in places, and unusually difficult to kill. Multiple ships reported encounters with this same whale over roughly 2 decades, and accounts from the era describe him fighting back against harpoon boats with a level of aggression that stood out even in an industry built entirely around violent confrontations with whales. What makes Mocha Dick's story different from a simple monster tale is the pattern behind it. According to historical accounts, this specific whale had already survived numerous earlier attacks by the time later crews encountered him, his body reportedly scarred from old harpoon wounds, evidence of fights he had lived through before. An animal that has already been stabbed, chased, and nearly killed multiple times by boats carrying men with harpoons is an animal that has learned, through direct, repeated pain, exactly what a whaling ship represents. This lines up perfectly with what modern behavioural scientists now understand about learning in highly intelligent animals. Elephants that survive poaching attempts in one region have been observed becoming warier, more defensive, and occasionally more aggressive toward vehicles for the rest of their lives. Chimpanzees that witness violence within their own troop change their behaviour toward outsiders permanently. Sperm whales, with brains larger than any other animal on Earth and complex social structures built for sharing information, appear capable of exactly this same kind of learning. Mocha Dick likely was not born aggressive. He became that way, shaped by repeated direct violence from the one predator capable of actually threatening him: humans in wooden boats. His story, and Herman Melville's decision to blend it with the Essex disaster years later, gave the world Moby Dick, a work of fiction built almost entirely from real behaviour, real trauma, and a real whale who had every reason, based on his own history, to fight back. The question this raises reaches far beyond one legendary whale. If a single sperm whale can learn to fear and resist a specific kind of ship after enough violent encounters, what happens to an entire species, hunted relentlessly across every ocean on Earth for over a century? For roughly 150 years, from the early 1600s through the mid-1900s, humans hunted sperm whales across every ocean on the planet, driven by a global demand for the oil found inside their massive heads. This oil-lit lamps in cities from London to New York lubricated machinery during the Industrial Revolution and became one of the most valuable resources on Earth long before anyone drilled for petroleum. At the peak of this industry, hundreds of thousands of sperm whales were killed, hunted down by fast ships and skilled crews who had turned whaling into a global enterprise. For a sperm whale living through this era, a ship on the horizon did not mean curiosity or safety. It meant small boats would soon be lowered into the water, harpoons would fly, and there was a real chance the whale, or another member of its pod, would not survive the encounter. Sperm whales are highly social animals that live in tight matriarchal family groups, meaning females and their calves stay together for life, while related whales share information, protect each other, and pass down learned behaviour across generations, almost like an oral history told entirely through sound. Researchers studying historical whaling logs have found something remarkable buried inside centuries of old ship records, evidence that sperm whale pods appeared to get harder to hunt over time within the same regions, as if entire family groups were somehow learning and adapting their behaviour in response to repeated attacks by ships. Some historians believe whales began changing their diving patterns, staying down longer, surfacing farther from ships, or scattering in different directions when boats approached, instead of remaining in a tight group the way undisturbed pods normally do. If true, this would mean an entire species adjusted its natural behaviour, potentially teaching these lessons to calves too young to have experienced the danger firsthand, purely based on the collective remembered trauma of encountering hunting ships. Modern commercial whaling of sperm whales largely ended by the 1980s, meaning the species has now had several decades of relative safety from the specific threat that once defined every human encounter. Yet elders in many long-lived, highly social species carry memories and behaviours forward for far longer than a human lifespan might suggest. This raises an important question about the calm, curious whales divers meet today. Are we truly witnessing a species that has always been naturally peaceful toward humans, or are we witnessing a species slowly, generation by generation, learning to trust again? If sperm whales really can learn and remember, the clearest evidence comes not from ancient whaling logs, but from research happening right now, using modern boats equipped with underwater microphones instead of harpoons. Marine biologists tracking sperm whale pods in several regions around the world have noticed a consistent pattern that seems almost impossible to explain any other way. The moment a research or tour boat's engine becomes audible underwater, well before the boat is anywhere close enough to actually see the whales, entire pods sometimes begin diving deeper or moving away, long before the vessel poses any real, immediate threat. This reaction seems to fade over time in regions where boats have consistently proven harmless, suggesting whales are not simply born fearing all engine sounds, but rather learn, region by region and generation by generation, which sounds are actually associated with danger. In areas with a long, heavy history of hunting, some populations appear more cautious even decades after whaling ended in that specific region, while whales in areas with less hunting pressure historically seem noticeably calmer and quicker to approach unfamiliar boats out of curiosity instead of caution. Researchers studying this pattern point to the sperm whale's coda system, the specific sequences of clicks these whales use to communicate within their pods, as a likely explanation for how this kind of caution could actually spread. If one whale, or one family group, experiences a dangerous encounter with a specific type of boat or engine sound, and that experience somehow gets reflected in the way they communicate or behave afterward, other whales interacting with that same pod could plausibly pick up on the pattern too, the same way a herd of animals in Africa passes along awareness of danger through shared alarm behaviour. This idea remains an active area of research, difficult to prove with certainty in wild animals scattered across an ocean too vast for constant observation. But the behavioural evidence keeps pointing in the same direction, toward an animal whose caution and calm are not fixed traits handed down blindly by instinct, but something closer to an ongoing, evolving relationship with the specific humans and boats each population actually encounters. That distinction matters enormously, because it means the peaceful, curious whale a diver meets today near a place like Dominica is not simply a lucky exception. It may be the direct result of decades spent proving again and again that not every human, and not every boat, deserves the same fear a whale a century ago would have felt instantly. In certain parts of the world today, encountering a sperm whale in open water has become something people can actually plan a trip around, a stark contrast to a species once defined almost entirely by violent one-sided encounters with whaling ships. Places like Dominica in the Caribbean have built entire tourism industries around responsible, closely regulated encounters, where trained guides bring small groups of snorkelers into open water specifically to observe resident sperm whale pods that live in the surrounding waters year-round. What happens during these encounters continues to surprise even experienced marine biologists. Whales in these areas often show minimal reaction to a small group of snorkelers entering the water nearby, sometimes continuing to rest, socialize, or even nurse calves within relatively close range. Behavior that would have seemed unthinkable during the whaling era, when any human presence signaled immediate danger. Guides who work these waters regularly describe individual whales they recognize by name, some of them animals they have observed calmly interacting with visitors for years, developing what almost looks like familiarity with the specific humans and boats that visit that same stretch of ocean season after season. Researchers studying these populations have documented calves born and raised within these tourism zones, showing similarly calm behavior from a young age, suggesting the trust being observed may already be passing from mother to calf, the same way older whales once apparently passed down caution and fear during the whaling era. This does not mean every sperm whale on Earth behaves this way. Populations in regions with less regulated boat traffic, or areas where illegal hunting or dangerous fishing practices still occur, tend to show far more caution around humans, reinforcing the idea that this behavior is learned and specific, not some universal trait hardwired into every sperm whale regardless of experience. What makes this genuinely remarkable is the timeline involved. Sperm whales can live 70 years or longer, meaning some of the oldest whales alive today were likely born while commercial whaling was still actively hunting their species. For an animal with a memory, a family structure, and a communication system sophisticated enough to pass down information across generations, choosing curiosity over fear after everything humans have historically done to this species starts to look less like an accident of nature, and more like something the animal itself had to actively decide. Cut open the skull of a sperm whale, and you find something no other creature on Earth carries, a brain weighing up to 18 pounds, roughly 6 times heavier than the brain sitting inside a human head. In raw size, nothing beats it. Not an elephant, not a killer whale, not even the largest dinosaurs that ever walked the planet. For decades, scientists assumed bigger automatically meant smarter, but research over the past 20 years has shown the picture is far more complicated than a simple scale. What actually seems to matter most is not total size, but structure, how tightly packed the nerve cells are, and how many folds and wrinkles cover the surface of the brain, since more folds mean more surface area packed into the same space, similar to crumpling a flat sheet of paper to fit more of it inside a small box. A sperm whale's brain is heavily folded, far more than a human brain, giving it an enormous surface area for processing information, even if the exact number of nerve cells inside remains difficult for scientists to measure precisely in an animal this large. What researchers do know is that big-brained, long-lived, highly social animals share a specific set of traits, and sperm whales check every box. They can live 70 years or longer. They form complex, lasting relationships within tight family groups. They use a sophisticated system of clicks to share specific information with each other across long distances. Scientists have also discovered something called spindle neurons inside sperm whale brains, a special type of nerve cell once believed to exist only in humans and a small number of great apes, cells linked to empathy, social awareness, and complex emotional processing. Finding these same cells inside a sperm whale's brain does not prove the animal experiences emotion exactly the way a human does, but it strongly suggests the machinery for something like empathy, grief, or social bonding is physically present and active. This raises a genuinely fascinating possibility about every calm encounter divers describe. When a sperm whale turns one eye toward a stranger in the water and simply watches, it may not be a blank instinctive reaction at all. It might be an actual moment of assessment, playing out inside the largest, most complex brain on the entire planet. To understand where that kind of complex social awareness actually comes from, you have to look at the tight structured society sperm whales are born into, a society built almost entirely around female relationships that stretch across generations. Female sperm whales and their young almost never travel alone. They live their entire lives inside tight social units, groups of roughly 10 to 20 related females and calves who stay together for years, hunting together, protecting each other, and even nursing calves that are not their own. Adult males leave these family units once they reach maturity, roaming the ocean largely alone or in loose bachelor groups, returning only occasionally to mate before disappearing again into deeper, colder water. Researchers studying sperm whale populations across the Pacific Ocean discovered something even larger sitting above these small family units. Enormous groups called clans, some containing tens of thousands of individual whales spread across thousands of miles of ocean. Remarkably, different clans can share the exact same waters, hunting in the same general area without ever actually socializing with each other, almost like two different towns built right next door but never mixing at the local diner. Scientists identified these clans using an unexpected clue: the specific patterns of clicks each group uses to communicate, patterns so distinct between clans that researchers can identify which clan a recording came from without ever seeing the whale itself. This entire system depends on learning, not instinct. Young calves are not born already knowing their clan's specific communication style. They learn it the same way a human child learns to speak, by listening closely to their mothers and other adult females within their family unit, absorbing patterns over months and years until the dialect becomes second nature. This detail matters enormously for understanding how sperm whales might pass down more than just communication style. If clicking patterns can be taught and learned within a family group, generation after generation, then behavior, including caution around humans or comfort around a specific type of boat, could plausibly travel the exact same path, passed from an experienced mother to a curious young calf swimming close by her side. This is precisely the mechanism many researchers now believe may explain the difference between wary whale populations in regions with a heavy hunting history and remarkably calm populations in places like Dominica, where trust appears to have been rebuilt, one careful lesson at a time across multiple generations. The click itself, the exact tool used to teach these lessons, turns out to be even more sophisticated than most people realize. A genuine language built entirely out of rhythm and silence. Listen closely to a group of sperm whales underwater, and you will not hear one continuous stream of sound. You will hear short, patterned bursts, sequences scientists call codas, each one built from a specific number of clicks arranged in a specific rhythm, almost like a short phrase in Morse code tapped out again and again. One coda might be 3 quick clicks followed by a pause, then 2 more. Another might stretch the final click slightly longer than the rest, a tiny detail a human ear would likely miss entirely, but one that whales themselves seem to notice and respond to with precision. Researchers working with massive data sets, tens of thousands of recorded codas collected from oceans around the world, have identified dozens of distinct coda patterns used across different sperm whale populations. Some of these patterns appear to function almost like names or greetings, specific codas used consistently between individuals who already know each other well, almost like a familiar nickname exchanged between old friends. Other codas appear tied to specific group activities, coordinating a dive, or gathering the family unit back together after everyone has spread out to search for food across a wide area. What makes this discovery genuinely remarkable is how closely it resembles the basic building blocks of human language. Small, repeatable units combined and recombined to create different messages, learned socially rather than known automatically from birth, and varying meaningfully from one social group to the next. No scientist claims sperm whales possess language in the full sense that humans do, with grammar, abstract concepts, or the ability to discuss things that happened somewhere else at some other time. But the foundation, a learned, structured communication system used to coordinate complex social behavior, is undeniably present and undeniably sophisticated. This raises a tantalizing, still unanswered question. If sperm whales can develop specific codas to identify individuals, coordinate group behavior, and mark clan identity. Could they also develop and share specific communication patterns tied to unfamiliar creatures they encounter repeatedly, patterns that essentially function as information about us? No confirmed evidence exists yet proving whales have a specific coda meaning human or boat, but the underlying communication system is unquestionably capable of that kind of specificity. To understand exactly why this ability might matter so much to a species like the sperm whale, you have to look at the world where nearly all of this communication actually takes place. A world thousands of feet below the surface where sound is often the only thing that works at all. Descend 800 feet into the ocean, and sunlight has already faded to almost nothing, a dim blue twilight where most colours have simply disappeared from view. Continue down past 3,000 feet, and true darkness begins, a world with zero natural light except for the occasional flash of a bioluminescent creature, glowing briefly before vanishing again into black water. Sperm whales regularly hunt at these depths, and some individuals have been recorded diving even deeper, past 8,000 feet, deep enough that the ocean floor itself would be nearly 2 miles beneath the surface directly above them, roughly the height of 14 Empire State Buildings stacked one on top of another. At these depths, water pressure becomes almost impossible to imagine using ordinary experience. Every 33 feet of depth adds roughly 1 additional atmosphere of pressure, meaning a sperm whale hunting at 3,000 feet is enduring pressure over 90 times greater than what a person feels standing on a beach. A human body without serious protective equipment would be crushed by internal injuries within minutes, at even a fraction of that depth, lungs collapsing, gases dissolving dangerously into the bloodstream, long before reaching anywhere close to where a sperm whale comfortably hunts every single day. This extreme environment explains almost everything unusual about a sperm whale's body. The dense, oil-filled head exists partly to help the whale control buoyancy at extreme depth. The powerful echolocation system exists because eyesight becomes almost useless in total darkness. Even the whale's famous ability to survive without breathing for long stretches exists specifically to make deep, dark hunting possible in the first place. This is the actual world sperm whales are built for, a crushing, lightless alien landscape that could not be more different from the sunlit surface waters where humans swim, dive, and occasionally cross paths with a resting whale. When a sperm whale rises up from this world to breathe, it is stepping briefly into an environment as unfamiliar to its daily life as the bottom of the ocean would be to us. The gap between these two worlds is not small. It requires one of the most extreme physical adaptations found anywhere in the animal kingdom, one that lets a sperm whale hold its breath longer than almost any other creature that breathes air. The world record for a human holding their breath underwater, achieved by elite-trained freedivers under carefully controlled conditions, sits at just over 24 minutes, an extraordinary feat that requires years of specialized training and pushes the human body to its absolute limit. A sperm whale does this every single day, multiple times, without any special training at all, regularly diving for 45 minutes to an hour, with some recorded dives stretching past 90 minutes on a single breath. The difference comes down to biology built specifically for this exact challenge. A sperm whale's blood contains dramatically higher concentrations of a protein called myoglobin compared to a human's, a molecule that binds and stores oxygen directly inside muscle tissue, essentially turning the whale's entire body into a portable oxygen tank distributed throughout every major muscle group. Before diving, a sperm whale can also redirect blood flow away from less critical organs, concentrating oxygen supply toward the brain and heart, the two systems that absolutely cannot function without it, while temporarily reducing flow to areas that can tolerate lower oxygen levels for a while. Even a sperm whale's heart rate drops dramatically during a deep dive, sometimes falling to a fraction of its normal resting rate, conserving precious oxygen the same way a car saves fuel by shutting off the engine at a red light instead of idling continuously. Perhaps strangest of all, sperm whales appear largely immune to decompression sickness, the dangerous condition divers call the bends, caused when nitrogen gas dissolves into the bloodstream under high pressure and then forms dangerous bubbles if a diver rises too quickly. Human divers must ascend slowly and carefully to avoid this exact danger. Sperm whales, despite repeatedly diving to extreme depths and then rising rapidly back toward the surface, seem to avoid this problem almost entirely, likely due to specialized lung structures that limit how much nitrogen actually dissolves into their blood in the first place, Every single one of these adaptations exists purely to make survival possible in one specific, extreme environment. The deep hunting grounds where a sperm whale spends the overwhelming majority of its life. And waiting in that exact environment is the one creature capable of putting up a real fight against an animal this powerful. A creature with 8 arms, a razor-sharp beak, and eyes larger than dinner plates. Far below where sunlight reaches, in the same crushing darkness where sperm whales hunt, lives a creature that sounds like it belongs in a science fiction movie rather than the real ocean. The giant squid, scientific name Architeuthis, can grow to lengths exceeding 30 feet when you count its 2 long feeding tentacles stretched out fully, making it one of the largest invertebrates, meaning an animal without a backbone found anywhere on Earth. Its eyes are the largest in the entire animal kingdom, some measuring nearly the width of a soccer ball, an adaptation scientists believe helps the squid detect even the faintest trace of bioluminescent light stirred up by an approaching predator in otherwise total darkness. Unlike a fish or a whale, a giant squid has no internal skeleton at all, its entire body built from dense, powerful muscle, wrapped around a soft interior, propelled through the water using jet propulsion, forcefully expelling water to launch itself forward in sudden, explosive bursts of speed. 8 thick arms and 2 much longer tentacles line its body, each covered in rows of powerful, toothed suckers, strong enough to leave lasting marks on almost anything they grip tightly enough. At the centre of all those arms sits a hard, sharp beak, similar in shape to a parrot's beak but built from a material nearly as hard as a fingernail, strong enough to slice through tough prey with real force. For centuries, giant squid existed almost entirely as legend, blamed for stories of sea monsters dragging ships beneath the waves, since almost no human had ever actually seen one alive in its natural deep-water habitat. Even today, footage of a living giant squid in the wild remains extraordinarily rare. Most of what scientists know pulled instead from squid that have washed ashore already dead, or been pulled up accidentally in fishing nets. What we do know for certain comes from an unlikely source, the stomach of a very different, much larger predator, sperm whales, whose stomachs have been found packed with giant squid beaks that refuse to digest, stacking up over a lifetime like grim souvenirs from countless deep-water battles most of us will never actually witness. Examine the skin around a mature sperm whale's massive head closely, and you will often find something strange. Circular white scars scattered across the surface, some small, some nearly 4 inches wide, ringed with tiny tooth-like marks around their edges. These are not injuries from fighting other whales, and they are not caused by boats or fishing equipment. They come from giant squid, specifically from the powerful toothed suckers lining each of the squid's 8 arms and 2 long tentacles, weapons a desperate squid uses in the final, violent moments of a hunt it has no real chance of winning. When a sperm whale locates a giant squid in the crushing darkness of the deep ocean, the squid does not simply give up without a fight. It wraps its arms tightly around the whale's head and body, gripping with everything it has, suckers biting into skin with enough force to leave permanent, lasting marks, even after the encounter ends. Scientists examining stranded sperm whales have documented these scars repeatedly, sometimes dozens scattered across a single animal's head, each one a physical record of a specific violent encounter that took place somewhere in the deep, dark water, completely hidden from human eyes. Despite the squid's genuine effort, these fights are never truly close. A mature sperm whale can weigh over 100 times more than even a large giant squid, giving the whale an overwhelming size and strength advantage that no amount of gripping or biting can realistically overcome. Marine biologists who study this ongoing struggle describe it as an evolutionary arms race stretching back millions of years, squid developing larger eyes and faster reflexes to detect and evade approaching whales, while whales developed more powerful echolocation and deeper diving ability specifically to keep finding squid no matter how well they tried to hide. This entire, silent, brutal conflict happens constantly, somewhere in the deep ocean, every single day, completely invisible to the world above the surface. It represents the sperm whale's real, ongoing struggle for survival, a genuine predator versus prey battle fought with real stakes and real physical cost. Compare that violent, high-stakes deep-water world to the calm, gentle curiosity a sperm whale shows toward a human diver floating quietly near the surface, and the contrast becomes almost impossible to ignore. Step back far enough, and the relationship between sperm whales and giant squid stretches across a timeline that makes human history look like a single passing moment. Scientists studying the fossil record and the evolutionary history of both species believe this deep ocean rivalry has been playing out for at least 20 million years, long before the first early humans ever stood upright on land, long before any land animal had even evolved into anything resembling a modern mammal. For most of the previous 500 million years, cephalopods, the group that includes squid, relied mainly on camouflage and quick colour changes to avoid predators that hunted using eyesight. Everything changed roughly 34 million years ago when toothed whales evolved echolocation, suddenly gaining the ability to hunt effectively using sound instead of sight, allowing them to chase prey directly into the darkest parts of the ocean where eyesight had always provided safety before. Giant squid responded over millions of years by evolving those enormous eyes, tuned specifically to detect faint traces of light, giving them crucial extra seconds of warning before an approaching whale gets close enough to strike. Sperm whales responded in turn by developing louder, more precisely focused echolocation, along with the ability to dive deeper and hold their breath longer, closing whatever advantage the squid's early warning system provided. This back and forth, one species adapting, the other adapting in response, over and over across millions of years, is exactly what scientists mean when they describe an evolutionary arms race, and it is still actively happening today, right now, somewhere in the deep ocean while you read this. What makes this ancient rivalry genuinely remarkable is what it reveals about sperm whales themselves. This is a species that has spent millions of years locked in a real, physically demanding struggle for survival, evolving specialized weapons and specialized senses specifically built for this one relentless conflict. Humans have existed as a species for a mere fraction of that time frame, and modern humans have only been swimming, diving and encountering sperm whales in open water for a tiny sliver of even that short amount of time. We are not part of this ancient evolutionary story at all. We are recent, unfamiliar, and completely disconnected from the one real predatory battle that has actually shaped this animal's body and behavior across millions of years. Every fight in nature carries a cost, even for the animal that wins. A lion hunting a full-grown zebra risks a broken jaw or a serious injury from a well-placed kick. Danger's real enough that lions frequently choose to leave weaker, safer targets alone, rather than risk unnecessary harm chasing something stronger. This same basic principle, sometimes called optimal foraging by scientists who study animal behavior, applies just as strongly to a sperm whale deciding how to respond to an unfamiliar creature floating nearby in open water. A giant squid fighting for its life provides a sperm whale with something genuinely valuable, a massive calorie-rich meal capable of fueling the whale's next several days of survival, worth the risk of a few scars from grasping tentacles and sharp suckers. A human floating at the surface offers nothing close to that same reward. We are far too small to provide any meaningful nutrition to an animal that regularly eats squid weighing hundreds of pounds, and unlike a squid, we present zero benefit worth risking any potential injury or unnecessary energy expenditure to pursue. From a purely practical standpoint, a sperm whale investigating a human diver has genuinely nothing meaningful to gain from aggression, and at least some small real cost to lose, whether that cost is wasted energy, a minor injury, or simply time spent on something that provides no actual benefit. Scientists who study predator behavior across many different species have observed this same basic pattern again and again. Animals capable of causing serious harm frequently choose not to, specifically in situations where aggression offers little genuine reward. A grizzly bear encountering a hiker on a trail usually retreats rather than attacks, despite easily possessing the physical power to win that encounter without difficulty. An elephant investigating a parked vehicle typically loses interest and wanders away rather than escalating the situation into something dangerous. Restraint, in other words, is not the same thing as weakness. It is frequently the smarter, more efficient choice for a genuinely intelligent, powerful animal that has learned to accurately weigh real risk against real reward. When a sperm whale approaches a human, observes carefully for a few quiet moments, and then simply swims away without incident, it is very likely making exactly this same practical calculation, one perfectly suited to an animal carrying the largest, most complex brain of any creature currently alive on planet Earth. But choosing not to fight a human is only half the picture, because the deep ocean itself remains one of the most genuinely dangerous environments in existence, filled with real threats that have nothing at all to do with human encounters. Imagine standing at the bottom of an Olympic-sized swimming pool, feeling water pressing in around your body from every direction. Now imagine that same pressure multiplied roughly 100 times over, the crushing force waiting at just 3,000 feet beneath the ocean's surface. A depth sperm whales visit casually and repeatedly throughout an ordinary day of hunting. Human bodies were never built to survive this kind of pressure without serious specialized equipment. Without proper protection, a human descending rapidly to these depths would experience nitrogen narcosis long before reaching anywhere close to that point, a dangerous mental fog caused by gases behaving strangely under intense pressure, similar in some ways to the disorienting effects of alcohol, except occurring while someone is critically dependent on clear thinking to survive. Continue descending further, and oxygen itself becomes dangerously toxic to the human brain at high enough pressure, a genuinely bizarre and counterintuitive danger where the very gas required for life becomes actively harmful in large enough concentrated amounts. Even a diver who somehow survived the descent itself would face an equally dangerous problem coming back up. Rising too quickly allows nitrogen that dissolved into the bloodstream under pressure to form small dangerous bubbles as pressure decreases, a condition called decompression sickness, or the bends, capable of causing severe pain, permanent injury to joints and tissue, or death if it happens quickly and severely enough. Professional human divers train for years and still must ascend at a carefully calculated, painfully slow pace, specifically to avoid this exact danger, sometimes spending hours completing mandatory safety stops on the way back up from depths far shallower than where sperm whales hunt casually every single day. This is precisely the hostile, unforgiving environment sperm whales evolved to survive inside, a world genuinely more dangerous to an unprepared human than almost any encounter with the whale itself could ever be. It reframes the entire relationship between our two species in an important way. Sperm whales are not simply choosing not to harm humans out of some deliberate act of pure kindness. They exist in a world so fundamentally different from ours that meaningful conflict rarely even becomes a realistic possibility in the first place. The clearest exception to this pattern, the one situation where a calm, restrained sperm whale can suddenly transform into something far more dangerous, happens when a mother senses her calf is threatened. Sperm whale calves are born large, roughly the length of a small car, but they remain genuinely vulnerable for years, unable to dive to the extreme depths where adults hunt, and unable to hold their breath anywhere near as long as a fully grown whale can manage. This vulnerability shapes nearly everything about how a sperm whale family unit actually operates day to day. Adult females take turns diving deep to hunt for food, while at least one adult always remains near the surface specifically to watch over calves too young to safely follow the group down into deeper, more dangerous water. When predators approach, usually a coordinated pod of orcas specifically targeting the youngest, weakest member of the group, sperm whales respond with one of the most striking defensive behaviors documented anywhere in the animal kingdom, a formation researchers call the marguerite, or sometimes the rosette. Adult whales arrange themselves in a tight circle, heads pointed inward protecting the vulnerable calves at the very center, tails fanned outward toward the approaching threat, like the petals of a massive living flower built entirely from muscle and raw defensive power. Those powerful tails become genuine weapons in this formation, capable of delivering devastating blows to any predator that gets close enough to attempt an attack, turning what would otherwise be a helpless, exposed calf into a heavily defended target surrounded on every side by adults specifically willing to fight. This is precisely the situation where a mother sperm whale's normally calm, curious temperament can shift dramatically and immediately. Researchers who study wild sperm whale behavior consistently emphasize this exact point when explaining safety guidelines around these animals. A calm, curious whale investigating an unfamiliar diver from a comfortable, respectful distance is behaving completely differently than a mother who perceives any threat, real or simply mistaken, directed at her calf nearby. This single distinction explains nearly every documented case of genuine aggression, from sperm whales toward humans in modern times, situations involving a boat or a diver that accidentally, often completely unintentionally, got between a mother and her calf, or that lingered too close during an already stressful, high-alert moment. It is not random, unprovoked violence. It is the same fierce, protective instinct you would expect from virtually any devoted mother in the entire animal kingdom. Deer, bears, birds, suddenly asked to protect her most vulnerable offspring from something she genuinely cannot yet identify as safe or dangerous. Understanding this distinction becomes especially important when you look closely at the handful of genuine boat ramming incidents that have occurred since the infamous sinking of the Essex nearly 2 centuries ago. The Essex was not actually the only whaling ship destroyed by a sperm whale during the 19th century, though it remains by far the most famous. Records from that era describe at least half a dozen similar incidents. In 1851, the ship Anne Alexander was struck and sunk by a large sperm whale in almost the exact same stretch of Pacific Ocean where the Essex had gone down 30 years earlier, an incident that genuinely stunned Herman Melville himself, since it happened just months after he had published Moby Dick. Other ships, including the Pocahontas in 1850 and the Parker Cook the same year, were struck hard enough by angry sperm whales to sustain serious damage, though both managed to survive and limp safely back to port. Look closely at the actual details behind every single one of these documented incidents, and a clear, consistent pattern emerges immediately. In every case, without exception, the ship's crew had already been actively hunting the specific whale involved, throwing harpoons, chasing the animal relentlessly across open water, inflicting genuine serious pain and injury before that whale ever turned around and struck back. The whale that sank the Anne Alexander, for example, had already been harpooned directly by the crew's small boat, only moments before it turned and rammed the much larger ship itself. This detail fundamentally changes how these dramatic historical incidents should actually be understood. These were not cases of a peaceful, unprovoked animal suddenly attacking innocent sailors without any warning or reason. They were the direct, understandable response of an animal in genuine physical pain, actively defending itself against a very real, ongoing, sustained threat to its own survival. Commercial sperm whale hunting largely ended by the 1980s, and remarkably deliberate ship-ramming incidents essentially ended right alongside it. In the many decades since regular whaling stopped, there are no confirmed cases of a sperm whale intentionally ramming and sinking a modern vessel that was not actively, aggressively hunting it at the exact time of the encounter. This pattern lines up perfectly with everything else this species has shown us, again and again, across 2 centuries of direct human contact. Sperm whales are not naturally aggressive animals lashing out at random. They are simply, understandably capable of powerful, decisive self-defense when genuinely provoked, exactly the same as any other living creature pushed hard enough by an ongoing direct threat to its own life. If sperm whales rarely face genuine danger from humans, they are far from untouchable in their own natural world. One predator alone has been documented successfully hunting sperm whales in the wild, and it is not a shark, and it is not another sperm whale. It is the orca, commonly known as the killer whale, an animal far smaller than a sperm whale individually, but one that hunts using something a lone sperm whale simply cannot match: genuine teamwork. In one especially well-documented case off the coast of California in 1997, researchers watched in real time as a coordinated group of roughly 35 orcas systematically targeted a pod of 9 sperm whales over the course of nearly 4 hours. The orcas attacked in organized rotating waves, groups of 4 or 5 animals at a time striking repeatedly before pulling back and letting a fresh group take over, a deliberate strategy scientists have since nicknamed wound and withdraw, designed specifically to gradually exhaust a much larger, more powerful opponent over time, rather than through a single overwhelming strike. The sperm whales responded using their own well-known defensive formation, forming a tight circle with vulnerable individuals protected at the centre. But on that particular day, the sustained, coordinated pressure from such a large orca group eventually proved to be too much, and one seriously wounded whale was ultimately separated from the safety of the group and killed. What makes orcas uniquely capable of this kind of hunt comes down to raw intelligence and genuine teamwork, the same fundamental qualities that make sperm whales themselves such a remarkable, complex species. Orcas live in their own tight, highly organized family groups, communicate constantly during a coordinated hunt, and can specifically target the exact weak point in a sperm whale's otherwise powerful defensive strategy, deliberately picking out calves, elderly individuals, or already injured whales rather than risking a direct costly confrontation with a healthy, powerful adult male. This single fact matters enormously for understanding the full picture of sperm whale behavior toward humans. This is a species with real, documented natural enemies, animals genuinely capable of successfully killing even a fully grown sperm whale under the right specific circumstances. Yet despite facing this kind of legitimate danger from another intelligent predator, sperm whales still consistently choose calm curiosity, not aggression, when they encounter an unfamiliar human swimming nearby in open water. That consistent choice starts to look less like simple animal instinct, and more like something closer to genuine deliberate judgment. Consider everything this animal actually is. The largest predator with teeth that has ever lived on planet Earth, carrying the biggest brain of any creature currently alive, armed with a sonic weapon capable of producing the loudest sound on the entire planet, and equipped with a skull specifically built to survive devastating high-speed impacts. This is not a weak or a harmless animal by any measure. It is one of the most physically capable predators evolution has ever produced, fully equipped to dominate almost any encounter it might reasonably choose to enter. And yet, when this same animal meets a human being, by far the smallest, slowest, most physically vulnerable creature it is ever likely to encounter anywhere in the open ocean, the overwhelming consistent pattern across hundreds of documented modern encounters is calm, careful curiosity, not violence of any kind. This stands in sharp, striking contrast to almost every other apex predator most people learn to fear throughout their lives. Great white sharks frequently test unfamiliar objects in the water with an exploratory, investigative bite, a behavior that occasionally results in serious injury to an unlucky human, simply because sharks lack any other reliable way to examine something in the water. Grizzly bears can react instantly and unpredictably to a perceived sudden threat, sometimes with little to no meaningful warning beforehand. Sperm whales, despite possessing vastly more raw physical power than either of those animals, consistently choose a slower, more careful, more deliberate approach. They observe first from a respectful, comfortable distance. They rarely make direct, prolonged contact of any kind, and in the clear, overwhelming majority of cases, they simply move on entirely without any incident whatsoever. Marine biologists who have spent years studying and documenting this exact behavior increasingly describe it using language you might not normally expect from a scientific paper. Phrases like deliberate restraint or genuine curiosity, rather than the coldly mechanical, purely instinctive terms usually reserved for describing animal behavior in academic literature. Whether or not a sperm whale actually experiences anything resembling human curiosity in a way we could ever truly measure or fully understand remains a genuinely open scientific question. But the consistent, repeated behavior itself is undeniable and thoroughly, extensively documented across dozens of different research studies conducted in vastly different oceans around the world. An animal fully capable of violence, repeatedly, consistently choosing something else instead, is not a simple accident of blind evolutionary instinct. It looks distinctly like a choice, made over and over again by an animal genuinely capable of making one. Return for a moment to the diver hanging perfectly still in warm Caribbean water, watching an enormous shape rise slowly out of the surrounding blue. This single moment captures everything this story has been building toward from the very beginning. A sperm whale, the single largest predator with teeth that has ever existed anywhere on planet Earth, carrying a brain 6 times heavier than a human's, armed with the loudest weapon any living creature possesses, approaches a tiny, fragile human being floating alone and vulnerable in open water. It could end this encounter in a single instant, using nothing more than its enormous size and raw physical strength. It does not. Instead, it turns one massive eye toward the stranger in front of it and simply watches, careful and unhurried, the same unmistakable behavior researchers have now documented and confirmed again and again across dozens of separate independent encounters spanning multiple oceans around the world. This moment did not happen purely by chance, and it certainly did not happen because sperm whales are simply, inherently gentle by nature, with no history or context behind that gentleness. It happened because of everything this whale species has actually lived through across the centuries, generations of relentless, brutal hunting, followed by decades of learning, slowly and carefully, which specific humans and which specific boats might actually be safe to approach after all. It happened because this animal's entire specialized body and behavior evolved for an ancient ongoing battle against giant squid in the crushing deep ocean darkness, a genuine fight that has never once in millions of years actually involved us. It happened because on some level science still cannot fully explain or measure with total certainty. This animal appears to be making an active, deliberate choice, over and over again, using the largest, most complex brain currently alive anywhere on this planet. The diver eventually surfaces, gasping, her mind racing to process what she just witnessed firsthand. The whale continues on into the deep, dark water below, heading back toward a hidden ancient world of extreme pressure, echoing clicks, and battle-scarred giant squid, a world we can only barely glimpse from a comfortable distance, and can never fully, truly understand. What remains behind is a simple, undeniable fact that quietly reshapes everything you thought you already knew about fear, about power, and about the ocean's true, reigning apex predator. For centuries, humans told one specific story about sperm whales, a story about monsters, about vengeful demons of the deep dragging entire ships down into dark water, a story so powerful and so compelling it eventually helped inspire one of the greatest novels ever written in the English language. That story was never really about the whale at all. It was about us, about our own genuine fear of something vastly larger, vastly more powerful, and far more mysterious than we could ever fully hope to understand or control. The real sperm whale, the actual animal living quietly beneath the waves, tells an entirely different story. It is a creature capable of true, devastating violence when it is genuinely threatened, a creature that has, in extremely rare documented cases, destroyed entire ships built from solid oak. But overwhelmingly, consistently, when this same animal encounters a human swimming alone, unarmed, and completely vulnerable in open water, it chooses something else entirely: curiosity instead of aggression, careful observation instead of blind, instinctive violence, restraint instead of the raw, overwhelming power it undeniably, unquestionably possesses. This pattern reveals something genuinely important, not really about sperm whales themselves, but about the assumptions we humans routinely make about power and danger throughout the entire natural world. We tend to assume, almost automatically, that the biggest, strongest creature in any given room or any given ocean must also be the most inherently dangerous one present. Sperm whales quietly, consistently prove that simple assumption wrong, again and again, in ocean after ocean around the world. Real strength, the kind an entire species can apparently learn, demonstrate, and pass down carefully across many successive generations, is not really about the sheer capacity to cause harm when provoked. It is fundamentally about the consistent, deliberate choice not to, made freely, again and again, by an animal that genuinely, undeniably could. Divers who spend real time in the water with these remarkable animals often describe the exact same lasting feeling once the encounter has fully ended. Not fear and not simple relief that danger has passed, but a strange, quiet, permanent respect that stays with them long after they climb back onto the boat. Because in the end, this is not really a story about the ocean's most powerful hunter choosing, for whatever reason, to spare us. It is a story about what genuine trust can eventually look like, patiently, carefully rebuilt one single, calm, unhurried encounter at a time, between two of the most intelligent species that have ever lived on this remarkable, complicated, endlessly surprising planet.